The last thing that I want to cover in section 16.10, so I'm going back to the notes that I gave you for 16.10. When we were in this part 1, how to predict if a salt is acid, base, or neutral. And I came up with this, I gave you this table right here that we looked at that was how to predict based on the cation and the anion if we're looking at something that is acidic or basic or neutral. And the only thing I didn't explain in that video, the first video, is what we would do if the cation was acidic and the anion was basic. So this situation right here, what's going to happen if the cation is acidic and the anion is basic? And I told you we can't just predict that. We have to look data up for that. So let's take a look at how we would go about doing that if that was a situation that we were in. Here's the problem that we're going to look at. So here's our example. Is NH4CN acidic, basic, or neutral? So let's just start by pretending like this wasn't we didn't know that this was one of the tricky problems. We were just going to approach it like normal. So what we would do is first look at the cation. The cation for this is NH4 plus. And then we would look at the anion. The anion is Cn minus. So for cations can either be acidic or they can be neutral. Let's scroll up to our list of cations. The neutral cations are in group 1A or 2A, and everything else is acidic. And NH4 plus is just one of the examples that I gave you. So this is an acidic cation. NH4 plus is acidic. Anions can either be neutral or basic. So let's scroll up to how we make that decision. For anions, the neutral anions are these 5 right here, and that's not one of them. In fact, Cn minus is what we have, and that's listed as a basic anion. So this is a basic anion. And in this situation, we have the cation that wants to make this solution acidic. We have the anion that wants to make solution basic. Your instinct might be telling you they're going to cancel each other out and the solution is just going to be neutral. That's really, really unlikely. It's possible, but it's really, really unlikely. And the reason for that is because the extent of acidity for NH4 plus is not necessarily the same as the extent of the basicity for Cn minus. Like the NH4 plus might be really, 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 really acidic, and the Cn minus might be just a little tiny bit basic. In that case, that little basic cyanide is not going to be able to cancel out that overwhelmingly acidic NH4 plus. So we cannot assume that they cancel each other out. We have to look at data. We have to compare the acidic strength of NH4 plus to the basic strength of Cn minus. And the way that we compare them is with their Ka and Kb. Ka and Kb values can be found anywhere. So you can just Google what is the Ka of NH4 plus, what is the Kb of Cn minus, and you're gonna get those numbers. You also have data tables in your textbook and probably data tables on ALEX that give you Kas and Kbs. They're all over the place. So these Kas and Kbs, we're gonna look them up. They're somewhere out there for you to find. And I've already looked them up for you. So NH4 plus, the Ka is 5.6 times 10 to the minus 10. And for cyanide, Cn minus, its Kb is 2.0 times 10 to the minus 5. And our rule here is to just go with whichever, Ka or Kb, whichever one is bigger. And don't let the negative exponents trick you, because negative 10 is smaller than negative 5. So in this particular case, Kb is greater than Ka. The Kb value is a larger number than the Ka value, which means that the cyanide is a stronger base than the NH4 plus is an acid. And that's a confusing sentence. I don't want to write all that down because that sounds awkward. Cyanide is a stronger base, and it is overpowering the acidity of the NH4 plus. So what I originally drew on my squiggly lines was the other way around. Cyanide is a big, old, powerful, mean old base. And the ammonia is just a little weak acid. And the cyanide is overpowering the acidity of the NH4 plus. And that means that this compound, NH4Cn, is basic.